We are, you guys, what is going on? What is wrong with you?
Last class on Thursday, my worker comes out.
We're going to have a quiz. We're going to finish all this graphic, and then we're going to practice for the quiz that we're going to take the next time we're together, which is on Tuesday. So anybody who wants to do a little practice and take the quiz after school tomorrow can do that if you don't want to wait a whole weekend. Now, some of you may want to come to open gym and practice a little bit on Sunday. I'm fine with that too, but I want you to know you have the option, instead of waiting till Monday, because I don't see you tomorrow, you can take the quiz after school tomorrow. All right, but before we're ready to even start practicing on that, we have to finish up our graphic. So, here we go. According to my notes, we're ready for G. So we're going to graph a sine, a cosine, and a tangent. And this time, the extra number that I put in is in front of the x. Yesterday, when we were finishing up, our extra number was out here, right? Okay, these are in a different spot. So who remembers what the extra number in front of the x does, Pat?
It divides the width.
Exactly. So this number right here is going to divide the width. Now, if you have forgotten that, make a note of it, because the number out in front is going to divide the width. The number in front of the x is going to divide the width. All right, so how does that impact me? Well, it's not as bad as you might think. I'm going to start by graphing a sine curve. This problem, the first one we're doing here, is a sine. Okay, we are on page 37 of our notes. We're doing problem G, and it is a sine curve. So already I have half credit. If this is a test or a quiz problem, I have half credit because I have the shape right. That's my sine. That's what it looks like. Now, to get the other half credit, I have to do all of my labels. And I'm also going to be asked for the amplitude and period. Now, I know that in a normal sine curve, the basic definition sine curve, I know that these labels are what? 1 and -1. The only way to change those is to put a number out in front. Since there's no number out there in front, this is going to stay 1 and -1. So my amplitude is 1. That isn't going to change. The only way to change the height of your curve is to put a coefficient here in front, like a 2 or a 5 or a -3. Now, these labels are normally what? What are these labels normally? 90, 180, 270, 360. Perfect. And I'm writing them down below. Please don't write them up here. You're going to write your new labels up here. I know these are changing because I have put a coefficient in front of x, and that coefficient is going to divide all of these numbers. That's what that coefficient does. It divides the horizontal numbers, the width. So 90 divided by a half,
45.
no, 90 divided by a half is 90 times 2 over 1, and 90 times 2 is 180, and then 180 times 2, 270 times 2, and 360 times 2. So here are the new labels. They're all 2 times the original, because I had to divide by a half, which is the same as timesing by 2. That means my period now is 720 degrees, because the period is the distance from start to finish. Right? Okay. Now, let's try this one. I'm going to start by drawing my cosine curve. And my cosine is the one that starts up here, comes down and back up, right? Now pay attention. It starts at the top of the hill and it ends at the top of the hill. It doesn't end here. It ends at the top of the hill. So, I got half credit because I got the shape right. Now, tell me about the vertical labels here, these labels. What are they going to be? 1 and -1. Because they're always 1 and -1 unless you put a number here. And if you don't put a number there, then they're 1 and -1, which makes your amplitude 1. Right? Now, these labels are normally 90, 180, 270, 360. Those are the normal labels for my cosine. But what did I do? I put a 2 on the x. And what does that 2 do? It divides all these numbers. So this time, Anthony, that is going to be a 45 and a 90. Yep. So your period this time is 180 degrees. The coefficient in front of the x divides these labels. All right, now we have a tangent. Tangents, remember, are a little bit different. We've got an asymptote here and an asymptote here, and a dot at the origin. And then we'll draw our squiggly line, starting down and going up. Yesterday I had one that started up and went down. Why was that? Because of the negative out in front. Remember, negatives out in front tip you upside down. Right? So here's my shape. Now I know that a normal tangent has asymptotes where? What are these two labels? -90 and 90. But I put a coefficient on x, which is going to divide these. So 90 divided by a 4th is 90 times 4, which is 360. So this is -360 and +360, which means my period, now watch this one, it's not 360, the period is 720, because the period is start to finish. So since it's 360 on each side, it's going to be a total of 720. What's the amplitude for my tangent? Undefined, none. Very, very good. Very good. Okay? Let's see what we've got next. Okay, now we're going to put it all together. So we have -2 sine 1/3 x. We have 1/4 cosine 1/4 x. And 2 tan 1/5 x. Here we go. Yes.
For the amplitude, and what always be?
Yes.
Okay.
No answer. Empty set.
Okay.
For the amplitude of the tangent, every tangent curve in the whole wide world is going to have no amplitude. No amplitude. Because it goes up and down forever and ever, so there's no way to define its height. So even before you do this, I don't know what the period is, but I know the amplitude here is going to be nothing, even before I do anything. Because that's what it is for tangents. Okay. Now, first thing I'm going to do is draw my shape. What do I have to pay attention to in this problem? There's two numbers in there, but as far as the shape goes, there is a negative, and the negative is going to turn it upside down. Q, you awake, my dear? You feel okay? All right, let's stay focused. All right. All right, so here's my sine curve. I'm going to go down and then up. I have to pay attention to that negative because that's going to affect the shape. This one's going to be upside down. It's a sine, so it has a valley and then a hill. Right? So now I'm going to work on, oh shoot, this isn't right, is it? I kind of did that automatically, but that's not right. What should those labels be? Look out here in front.
-2 and 2.
That should be 2 and -2. My amplitude is 2. We talked about that yesterday. Does everyone remember? This is a multiplier, so it's going to make it twice as tall. So instead of 1 and -1, it's 2 and -2. Now I know these labels are supposed to be 90, 180, 270, 360. I know that's what they are supposed to be. But what does this do? That divides the width, right? So I'm going to have to divide these numbers by 1/3. So 90 divided by 1/3 is 90 times 3.
270.
So this one's going to be 270, 540, 810, and 1080. That's exactly right. So our amplitude is 2, but our period is 1080 degrees. I think somebody said that's a huge curve. Yes, it is. It would be very, very long. All the way to 1080. All right, you getting the hang of that? All right, let's look at the next one. It's a cosine. It's positive. So let's start by drawing a positive cosine. And please check your work. Make sure that you're drawing it from top of hill to top of hill. That's how it should be drawn. Top of hill to top of hill. I almost put 1 and -1 again, but it's not 1 and -1. This time it's what? 1/4 and -1/4. Your amplitude is 1/4. All right, so here we go. It's supposed to be 90, 180, 270, 360. What's it doing? It's dividing, right? And so when I divide by 1/4, it's going to be 90 times 4. So my first one is 360, 720, 1080. Whoa, those are big numbers, aren't they? So my period is 1440 degrees.
active sign?
Text?
Do you like remember these numbers? Like 1/4 of y. I bet you just know these. Right?
Well, because I've done it a zillion times. Right. Okay, now I have a tangent. I've already figured out that the period, or I haven't figured out the period. I figured out the amplitude doesn't exist. So I'm going to have my two asymptotes. It's positive. So there's my picture. And I know what you're thinking. At least I hope I know what you're thinking. You're saying, Miss Ford, what's that guy doing out there? Right? What is he doing out there? Well, let me explain to you what's going on. But before I do that, I want you to know that you're not going to worry about it. All right? You are not going to worry about it. This thing has no amplitude, so the 2 is going to be meaningless for you. Now, the reality is that if I graphed a regular tangent, it would look like this. But if I put a 2 in front, it would just stretch it out a little bit more and make it more straight. You're not going to worry about that. You are going to ignore that 2. The only time that number is going to matter to you is if it is negative. Because if it's negative, it's going to turn the picture upside down. But the number itself is irrelevant to you. You're not going to worry about it. Mrs. Ford has told you it changes the curvature, but since we're not plotting any points, we're just drawing a quick sketch, that doesn't matter to us. Only for tan. What happened?
It's asking to sign into iTunes.
Oh, did you say cancel?
Yeah.
Okay, thank you. I don't know why it does that all the time. It drives me crazy. Okay, I don't even know how to sign into iTunes. I don't know why it does. All right, so we've cleared up that we don't worry about the 2, right?
Right.
Okay, but we do have to worry about this guy. So we know our normal asymptotes are at 90 and negative 90, right? But we're going to have to divide those numbers by a 5th. So what is 90 divided by a 5th?
400.
90 times 5, which is negative 450 to positive 450, which means your period is 900 because period goes from start to end, asymptote to asymptote on a tangent. All right, we got 2 more. What are you doing there, Charlotte? What are you doing? Okay, stay focused. Okay, now we got 2 more, and then we're going to do a little bit of review. Okay, so here we go. Last 2 on this page. Hunter, trust me, they do not need distraction. Tangent. I know I'm going to have an asymptote here and an asymptote here. It's a positive tangent, so it's going to squiggle up through the origin. That's what it's going to look like. I know that there is no amplitude. And I know that the period should be from negative 90 to 90. But I have a 10 in there. So I'm going to divide by 10. Remember, this number divides. So what are these labels actually going to be? Negative 9 and 9? which means my period is a whopping 18 degrees. So if I were actually doing this to scale, it would be very, very skinny, right? Very, very small. All right, one more. I got a sine curve. So there's my sine shape. Everybody should have that, right? So now I'm going to put my labels on. What about these? 1 and -1, because the only way to change that is to have a number out here, and I don't have one. So my amplitude is 1. I may need a little calculator help with this one, text, because 91, 82, 73, 60, those are my starting numbers. But that guy is going to divide those, right? So 90 divided by 2/7 is 90 times 7/2. Is that right? So I got 315, 630, 945, and
1260.
1260. Wow. So the period is 1260 degrees. Now we are not done for today. We're going to do a quick review and then keep moving. Shadow? How we got 315? Okay, it's 90 divided by 2/7, which is 90 times 7/2. So that's 630 over 2. Divide 2 into there, you get 315. And then do the same thing with 180 and 270 and 360. Another way, is if you don't want to do the arithmetic with each of these, if that distance is 315, all you have to do is add another 315, and then add another 315, and add another 315. So you can do it that way too, if that's easier for you. All right? So, do you have a piece of paper? I don't have a practice quiz written out for you, but I know exactly what it's going to look like. So, if you have a clean sheet of paper, that would be great. If you do not have a sheet of paper, why don't you see if your friend has one for you?
Thank you, thank you.
Who needs one? No. 5 cents.
All right, so everybody's got a sheet of notebook paper out. At the top, I want you to write practice quiz 4.3, 4.4. Here's my fear. I think, since I don't see you tomorrow, I'm afraid some of you are going to forget we even have a quiz, much less when it's over. So please write that at the top. All right, and the first part of the quiz, well, you know how I have to mix things up because they're different quizzes. The A part of the quiz is going to say evaluate. And it's going to have problems on it like this. Sine 300, secant 5 pi over 6, cotangent pi, and tangent negative 135. Alright, so the directions are going to say evaluate, and then the problems are all going to look like this. Now, these are all done exactly the same way. What do I do first here? No, this is a no calculator problem. I'm sorry. This is no calculator. I'm doing this without a calculator. So what do?
Draw a picture.
Draw a picture. That's exactly right. So when I draw a picture, I have to know where to put 300. So I need to remember that 0, 90, 180, 270, 360 is how I label angles in trigonometry. Are you remembering this? So then I'll figure out where 300 goes. Won't 300 go down here? So I'm going to go around and draw my angle and then make my butterfly bow tie. So this is 300 degrees. Now I always get out my colored marker here because this is so critical. You have got to figure out this angle and get it right, or you're going to end up with the wrong answer. So if this is 300, it's 60. Do not ever, if you're doing your subtraction, and I don't know how you're doing it, I don't know what's going on in your head, but I do 360 minus 300. That subtraction will never, ever, ever involve 270 or 90. You are not going to use those in your calculations, ever. I don't want to see 300 minus 270. That's wrong. You need to use 360 or 180, depending on which side you're on. Okay? Now, once I know that's 60, then I can label these sides. I know that's 1, that's root 3, and that's 2. And then I have one more caution. Are any of them negative? You know something is because it's not in quadrant 1. If it's not in quadrant 1, there's some negative in there somewhere. Root 3 is negative. Right? So I'm ready to answer the question. I want the sine. The sine would be what? Negative root 3 over 2. Because sine is opposite over hypotenuse. And it's always this angle right here at the origin. That's always the angle you're referencing from. Okay? All right. Secant 5 pi over 6. Same exact problem, type of problem, except there's an additional first step. What should I probably do first?
180 times 5.
Exactly. Actually, I think I'll do, since I'm not going to have a calculator, I'll do 180 divided by 6. That's 30. Times 5 is 150. So I'm finding the secant of 150 degrees. Logan, you can do 5 times 180. It just gives you big numbers that way. So I like to divide first. Okay, so I'll draw 150. Where's 150 going to be? Over here, right? This is 150. Bigger than 90, but less than 180. What's that angle? 30. 180 minus 150. Do not ever look at the 90. So that's a 30, which automatically means what? 1 root 3, 2. Is that good? Negative root 3. Very good, Ashley. Got to remember those negatives, and that's a negative. Tex, you doing this?
Yes.
Okay. All right. What's the secant? Hypotenuse over adjacent. So it's going to be 2 over negative root 3.
Oh, but you got to change it.
Which is 2 root 3 over 3 negative, right? Yes. Negative 2 root 3 over 3. Perfect? Yeah. Perfect. All right, same thing here. What's pi?
180.
All right, so we're finding the cotangent of here's 180, right, kids? It's right on the axis. And what did we say yesterday or the day before? If we are on an axis, we have to use a circle. That's right. We're going to draw a circle And we're going to use our circular definition, which for cotangent, anybody know it?
X over
X over y. Cotangent is x over y. You can't do SOHCAHTOA because there's no triangle for an angle that's on an axis. You can only do triangles when they're sticking out like this, not when they're right on the line. All right, so we said we're going to draw a circle. There it is. I need to know what point this is, and I'm always going to let my radius be 1. So if I'm at the origin and I go left 1, negative 1, comma 0. All right, so that means x is negative 1 and y is 0. Right there, that point. That's your x and your y, right there, always. So I want x over y, so x over y will be negative 1 over 0, undefined. When do I have to draw the circle? When the angle is on the line. So it's going to be something like 90 or 180. It's going to be one of those what we call quadrantal angles. Now you can actually do circles for all these problems, but it's a little bit harder. So I prefer to do triangles for these, but if you like circles, you can do them for all of them.
What would X not be negative?
What if you were here?
Well, how do you get there?
Then x would be 0.
How do you get there? That would be
Huh? If the angle was 270. That's 270.
Okay, so either 180, 270, or 90.
Yeah, or 360. Yeah, I think I just said that. Yeah. Those quadrantal angles. All right, tangent, negative 135. That means instead of going up and around, I'm going to go down and around. And I'm going to stop about right there. Does where I stop make sense to everybody?
Yes, ma'am.
Bigger than 90, less than 180. So this is 180 over here. So how big is that guy?
45.
45. 180 minus 135. 45 degrees. So what are the sides?
across from 45 is 1, and the other one then is 32.
And
The 1 on the left side is negative, and then the other one is
they're
negative.
both negative, right?
Yeah.
Because we're in quadrant 3, and in quadrant 3, your x and your y are both negative. Now I want the tangent.
Which is
So opposite over adjacent,
which will be 1.
the tangent is just 1. So, everybody's clear on, you're going to have some problems that look just like this. Notice, I put some radians in, so you had to change them to degrees. We have a quadrantal angle, we have a negative angle. We know how to deal with all that, right? All right, so that's half the quiz. The other half is going to say sketch. So here we go. Not a coincidence, we have a sine, cosine, and tangent, right? Those are our 3 shapes that we need to know. So here we go. Oh, and in addition to that, you're going to have to list the amplitude and period for each two. So you're going to sketch and list the amplitude and period. And I'm going to draw a grid for you just like this. And you're going to put your picture on it. Alright, so take a second and get the sketch on there, just the shape. Get the shape on there. Let's make sure that you can sketch a sine. It's positive, so hopefully you have this sketch. Is that what you got? So you should have a hash up here and a hash down here and hash, 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 hash. Okay, now, what are these going to be? 2 and -2, which means your amplitude is 2. These are supposed to be 90, 180, 270, 360, but they are going to be divided by 3. And this is a no calculator exercise, but I'm going to give you easy numbers like this. You can divide by 3. 90 divided by 3 is 30, 60, 90, 180, or 180, 120. Yeah, you can divide by 3.
Okay.
Now, if you're listening, if you're not good with the division, like apparently I'm not, remember what I told somebody a minute ago, once you put a 30 here, you know this is going to be plus 30, plus 30, plus 30, so you can do it that way. What's the period then?
120.
120 degrees, that's exactly right. All right, now we've got a negative cosine. Now, a negative cosine is going to start down here, go up and come back down, right?
Yes.
So he is going to start down and end down. That's my negative cosine. What are my vertical angles here? 1/2 and -1/2, meaning my amplitude is 1/2. Right? Now, what about my period? Well, these are supposed to be 90, 180, 270, 360. But what's happening? Divided by 2. So they're 45, 90, 135, 180. So your period is 180 degrees. Now please notice, I'm doing my work down below. Your answers should be up here on the graph, okay? This is my work, I'm doing it down below. Here is what I have to see. All right, one more of these, my friends. This is a tangent. So it's going to have an asymptote and an asymptote. And a squiggly line. What do you think I was double checking when I looked over at my problem before I sketched that in?
If the number was negative.
If there was a negative here. Because that matters to me. The 3 does not matter, so I am going to ignore it, and I'm going to put empty set here for amplitude. Because tangents have no amplitude. This is supposed to be negative 90 to 90. What's happening? I'm dividing by 1/2, and 90 divided by 1/2 is 90 times 2. So negative 180, 180. And my period is 360. Are we clear on what the quiz is going to be over?
Yes.
Are we? All right. Like I said, if you want to take it tomorrow during flex, we'll work on this a little bit, and then if you want to take it, then you can. You can take it tomorrow after school, or you can wait and take it Monday, which is when we'll take it as our class. We are not done. Please do not pack up. We are finished with our practice quiz, however. All right. So we don't have very much time, but we're going to go ahead and get started on this next section. We've kind of already done this a little bit.
I can feel my brain about to explode.
So I want you to think back a couple days ago when we did those squirrel in the top of a tree problems. And every time we did it, so let's say the tree was 10 feet tall and the nut was 18 feet from the base of the tree, and we wanted to find the angle. Do you remember what was special about this?
And how is this special?
We had, so the equation would be tan x equals 10 over 18. Remember that? Opposite over adjacent? But when the angle was what we were looking for, we had to use our second tangent button. And when you did that, this came out to be an angle, like 38 degrees or something, right? Okay, so when you see this notation, you know your answer is going to be an angle. So when I look at this first problem, and this is no calculator, exact value means no calculator. This is a no calculator problem. I know my answer is going to be an angle. That's what that notation means. Your answer is an angle. Now I'm going to draw a picture of this angle. What do I know about it? Its sine is 1/2. That's what this means. This means you have an angle whose sine is 1/2. Well, wait a second. That's a 1. That's a 2. What's this going to be? Root 3. Remember, no calculator. What kind of angles do I have to be working with? 30, 60, 90, or 45, 45, 90. No confusion there. It's going to be one or the other. How big's the angle that's across from 30. The 1? It's 30 degrees. So the answer to the question is simply 30 degrees. So you're working your triangle backwards from how you're doing it on the quiz. On the quiz, I'm going to say find sine 30. You're going to draw that picture and say 1/2. Now I'm working it backwards. I'm giving you the sine, and you're telling me what angle that goes with.
When you're drawing your triangle, do you always put it in quadrant 1 for these problems?
Yes.
Okay.
That's a great question. That can get quite messy, so we're going to stick with quadrant 1. Those are called the principal values, and that's just where we're going to be. All right, so now I've got the next one. See that notation, gang? That means there is an angle that has a cosine of root 3 over 2. It is really, really important that you get the root 3 and the 2 in the right spot, because you're going to have to know, okay, what goes over here? That's going to be the 1, and then this is going to be a 30 again. Please don't say to me, well, why do I get the same answer? Kids, you're always going to get the same answers. It's either going to be 30 or 60 or 45, right? Because those are the only ones we can do unless we have our calculator. All right. my triangle. Now, does it make sense to you that that's root 3 over 1?
Yeah.
So when you draw this, you're going to put the root 3 here and the 1 here. And that'll be a 2. And that'll be a 60. So the answer to the problem is 60 degrees. Now, Burkhart, go back to my question, or your question, I mean. Look at the next problem, and tell me what's the deal here. What's going to happen?
Would the opposite be negative?
Yeah. Can I draw this in quadrant 1? No, because there aren't any negatives in quadrant 1. So there are rules about the negatives, but I'm going to take those off your plate. I'm going to tell you what quadrant to draw it in. This is going to get drawn in quadrant 4. All right, so on a test or quiz, I'm going to make you that deal. I'm going to tell you what quadrant, and if I forget, you ask me, okay? Because I don't want you having to memorize yet more. You have enough to memorize. So, I want you to draw this triangle in quadrant 4. Something is 1, and something is root 2, and something is negative. So, can the root 2 be negative? No. So, it must be the one that's negative. And does that make sense in the picture? And then this would also be 1, right? Is that okay? And so what's this angle right here? 45. Okay, now wait a minute. What is this angle going to be? Can you figure that out? If this is 45, that is 315. And how did you get 315?
Because it's closest to 360 and there's 45
It's
degree
360 minus 45. That's exactly right. Do we ever use the 270? No. We only use the 360 or the 180. So it's 360 minus 45. Perfect. We'll do one more. Cosine, negative 1/2. All right, this is a negative. So I'm going to tell you what quadrant it's in. This one's in 2. So you're going to draw a triangle in quadrant 2, because I'm going to tell you that's where you draw this. Negative 1 and 2. Does that make sense to everybody?
Yes.
So this is root 3, making this angle 60. But 60 is not the answer. You got to start here, remember? So what angle would make a 60 right there? 120. How did we get 120? 180 minus 60. So that's 120 degrees. All right, that's magnificent, people. You know what's on the plate? We got a quiz. My guess is that we will be ready for a test at the beginning